Good afternoon and welcome to another Unreal 4 shoot 'em up tutorial. So today we will be adding the enemy base, and hopefully I think we should be able to add all of the enemy types in as well, which means that when we move on to the next video, which will be the enemy spawner, everything will kind of be ready to at least prototype spawning them into the world. So to begin doing this, if we go to our blueprints class, we will create a new folder and we'll just call this enemies. Now this will be using a lot of inheritance like we've done previously, so if we create a new blueprint class, this will be of type actor, and we'll just call this BP underscore enemy base. And with that created, we'll get the initial logic spawning in here to begin with. So if we go straight to the event graph, what I want to do is set the references and the variables for this class first of all. So these will be the variables which all of the child classes and all of the other enemies will share between them. So very generic variables such as we'll add the maximum health first of all, and if we just go over here and make sure that we'll turn this variable to be of type float, which means that any other variables that we make now will also be a float type, as we have a few others. So the next one we'll create is health, and then we want the movement speed. We're also going to add a little bit of randomization into the enemy movement, so we'll have a minimum speed and a maximum speed. And at some point, I know just from doing this previously that we'll also want to track the distance from the player. So they should be all of our float point values. So we'll leave that for now and we'll add the others as we go through. So the first thing we want to do is off of the event begin play, we want to get a reference to our game mode. So if we type in cast2 BP underscore game mode, that will find the game mode that we've created, which is also the one that we've set to be our active game mode. And then remember to actually find the game mode, we need to drag off of here and type get game mode. So this will just check this against the current game mode in play, which will be under our maps and modes. We have our game mode, so we'll check against that to make sure that it is BP underscore game mode and not something else like game mode or game mode base. And if that's successful, then we can promote this to variable and we'll just call this BP underscore game mode. So we know that when we see the references, that is relating to our own created game mode. And that just means that we can then use this later on in the blueprint if we need the reference to the game mode again. Now, whilst we're doing this, there's also going to be a function inside of the game mode that we're going to need a bit later. So if we go back to our blueprints, find the game mode and open this. And we're just going to very quickly create in the event graph a custom event, not a function, sorry. And we're going to call this, so find a new custom event, and we'll just call this update enemy count. So this will just be keeping track of the total number of enemies in the game. This will need one input of an integer type, and we'll just call this val for value. We'll come back and flesh this out a little bit more a bit later, but for now I just need that there so that we can drag off of here. So this is going to get access to anything inside of the game mode, and we can now find our update enemy count. And all we want to do is we'll be doing a simple calculation in the game mode later, and we just want to say that one new enemy has been added. So we'll just give that the value of 1. And then just compile that in both of the classes to get that to update correctly if you had any errors there. And then if we move along, we want to set a Boolean value, so we'll create a new value down here. We will change this to be of type Boolean, and we're just going to call this move direction. So the move direction will just be randomized, so we'll get the enemies to pan left or right, depending on how this comes out. So we're going to alt drag this in so that we can set this to begin with. And we will drag off of here and just simply call a function called random bool. So it's going to return true or false. And this will be used a little bit later in the movement of the enemies. Next off, we can drag off of here and we can set the movement speed. So if we get the move speed that we created earlier, we'll set that value based on, as I said, a random value. So we'll get a random float in range. And we'll just plug in the min speed and the max speed to control those two. And I like to give these quite a big difference. So for the min speed, I'll give this a value of 25, and the maximum speed, I'll give a value of 250. And the very last thing that we want to set up before actually adding any movement to the character or the enemy is the location at which it's spawned. So if we get actor location, so we'll find the get actor location node, we're going to drag off of here, we'll promote this to variable, and we'll call this the spawn location. So that will instantly store the value at which this starts, because we're going to create a spawner object or a spawner class, and this is going to spawn the enemies as a slightly random location across a panel, and this will find where this enemy was spawned, and we'll use that in a moment for an animation. So I'm just going to move these nodes down here and just make a comment around all of this just to remind ourselves what this is doing. So this is just the location where we're setting up all of the references and variables. Okay, so that reminds us later when we come back what's happening there. Now off of the spawn location, we want to get a timeline. So we'll add a new timeline and we'll just call this the spawn animation. So very similar to what we did in the player class. We're going to do that again for the enemies just because it adds that little bit more of an interesting approach to seeing the enemies appear on screen rather than just teleporting out of nowhere. So if we double click into the animation, what we want to do is we want a float track and we're going to add 2 keyframes. We want this to last for 1 second, so we'll turn that down to a second. The first keyframe we will put at the time 0 and a value of 0, and the second we'll put at the time 1 with a value of 1. And then all we're going to do is we'll drag select both of these, we'll right click on either one, say auto, and we'll just give that a bit of a curve. So it comes in faster and then eases off with the animation. And in fact, I think this might look a little bit cool. If we drag that one, we'll just put this at the time of, we'll try something like 0.75 so that it actually reaches its peak a little bit sooner. And then if we come back out of the timeline, we're back into the event graph. All we want to do is, whilst this is updating, we will set the actor location. So we'll get the set actor location node. And we want to lerp from the starting point to our endpoint. So again, we've seen this before. I won't take too long explaining what all of this is. Very similar to what we're doing in the player. So the start point we know is going to be the spawn location, which is why we stored this earlier. So that will be point A, if we drag that in there. The endpoint is going to be a float value, and because we're going down the screen, this will be a minus vector. So vector minus vector, and we'll plug that into the B value. So we'll find where we started minus the z-axis a little bit, which is I think about 120 units should be fine. And that will be where we want to end off. And then our new track, which is the speed that we just set up in the animation, will be the alpha value. And in fact, we'll just call that, we'll give that a name. If we come into this track, rename this, just call this entry speed. And again, very similar to what we had with the player, I'm going to create another Boolean. So I'm going to Control W our move direction, and we'll call this move enabled. And all we're going to do is make sure that this starts off as false. We'll alt drag this in. When this is finished, we'll set this to be true to make sure that the enemy is unable to move until the animation is finished. Otherwise, you can have weird things with the enemy trying to move across the screen while still going downwards as well. So we'll just make sure that it does the entire animation first, and then when the animation's finished, we will re-enable the movement for the enemy. And in fact, I think we could probably fit that in this video as well. So I'll just drag this again. We'll hit another comment here, and we will call this one the spawn animation. So we have our spawn animation, and if we go down to our event tick, we can just get rid of the collision for now, actually, it's in the way. So we'll get the event tick, and off of here, what we'll do is we will find our branch. So we'll immediately check whether the movement is enabled. And then if that is enabled, so we have finished the animation, we will set the actor location. And what we want the actor location to be is a vector plus a vector, so vector plus vector. And we're going to, for the first point, we'll get the actor location. And then off of here, we want to do a vector times a float. Now the float value is just going to be the delta seconds, purely to make this frame rate independent. So we'll have the enemies be moving at the same speed regardless of what frame rate your game ends up playing. So it just makes it more of a reliable experience. And then you've got an option here. We can either drag off of here and do a make vector, or we can just split the structure pin. And I think because this is quite small, this will probably look a little bit tidy if we just split the structure pin there, because the only movement we're interested in is the x-axis. So we're going to do a float times a float. And we want our movement speed to be the first argument. And then if we right click and find a select float node, we'll plug that into the second argument. And what we'll do is we'll give this either 1 or -1, depending on the move direction that we've set up above. And we're going to update this a bit later. When the enemy hits a wall, then that's going to be flipped to either be false or true, depending on what it wasn't previously. And then this will switch this to be 1 or -1. So we'll be multiplying a positive or a negative value against the movement speed, which will obviously invert the movement speed. So it will give us a left-right movement. So this isn't going to work fully at the moment, but this should at least get an enemy coming into screen and then doing something. And the final thing we know that every enemy is going to need is a static mesh. So if we come up here, we'll give this a static mesh, just replace that there. And all of these values, the speeds and the health and everything, we don't need to really fill these in here. What we'll be doing is that will all be updated in the inherited classes. So if we go back to the main window, in the enemy folder, we will right click the BP enemy base. We'll create a child class and we'll create our first enemy. So we'll just call this BP enemy 1. If we double click to come in here, we can see that we should have all of the variables over here. So we have the max health, the move speed, everything that we've put in the parent class. In the static mesh, what we want to do is come over and we'll find our enemy static mesh. And this is where we can fill in some of the values specific to this type of enemy. So this is going to be quite a simple enemy to kill. We'll give this 100 health or 100 max health. The standard health will be set up a bit later. The minimum move speed, leave that at 25 and 200 is fine. Spawn location, everything's going to be set up when the enemy is actually spawned. And if we just double check that in the event graph, we have a call to the parent's begin play and the parent event tick, and that is what's going to be firing the logic to get this moving without us needing to re-implement this again. And if we do the same thing a second time, we'll go back, we'll create another blueprint based on the enemy base, and we will call this one BP enemy 2. So if we go into BP underscore enemy 2, we'll do the same thing again very quickly. Now, one thing I do want to do on this one is we're going to add a unique variable just to this class, and we'll call this scale. This is going to be of type vector, and we want to make, if we compile this so we can give this a value, just because I don't have any other models at hand, I'm just going to make this bigger. So I'm going to make this 1.5, 1.5, and 2. In fact, 1.5, 1, and 2 for the scale of the actor. Just going to the construction script really quickly. And again, this is really simple, so it doesn't need too much explanation, but we're going to set the world scale, set world scale 3D, and we will just set that to be our scale value. So as soon as this is created, we will use the scale that we've plugged in there, and we will make this enemy or this static mesh slightly bigger. And again, we'll give that the pixel enemy static mesh and just come up to the values. And the other thing we'll change is we'll give this one more health. This is going to be kind of like a boss creature. So we'll give this one more health, and we'll also give it the option to move a bit faster. So we'll override the speed to be 50 and 400. So when this comes in, it'll be slightly less frequent, but it will be slightly more difficult to kill. Now, I've just tried compiling this, and if you see that the static mesh hasn't been found or it's coming up with something weird, simply because in the base class we've made this change but we haven't compiled it, so it kind of knows it's there but it hasn't finalized it. So if we compile from the base class and then go back to enemy 2, we can see that's been cleared up, just in case you get the same kind of issue. That's why you're seeing that there. Quite good that that happened on video so I could explain it and show it happening. So with that done though, we'll go back to the main window and we can drag in enemy 1 and enemy 2. Then if we hit play, we can see that they come in. So we've got the spawn animation happening, and then they're randomizing the speed and the direction they move. So we now essentially have our first 2 enemies, which is going to be perfect for prototyping. We can see them, they're doing something, which means we can move on to one of the more interesting things, which will be the enemy spawner in the next video. And we can add some logic to spawn these enemies at random intervals. And I've also set it up that the boss will come in based on every so many times you kill the standard enemies. And there was one other enemy class, but it's slightly more unique, so it's going to be easier to set these up. And then I'm going to add in these really kind of old school asteroid type enemy, which is just going to be something completely unintelligent. It won't have any movement apart from falling down the screen, and it's going to hit the player ship purely by the player not paying enough attention. But because that's very unique, it doesn't really take much from the base class. I'm going to focus on these 2 first of all, because we can pretty much set up most of the logic just once, and we'll have 2 completely different enemies in play. And then we'll just go back and add the asteroid a little bit later. Okay, so I'll leave this one here for today though. It's getting a little bit longer than I wanted. Just to mention very quickly as well that if you haven't already checked out the Patreon page that I've set up for this channel, do have a look over there. For anyone interested in the project files I use, so I've got a template, which is already the complete game, which I showed at the beginning of this playlist. I'm offering a current kind of early access to that project file. And then what I'll do is once this whole playlist is done, I'll be releasing the file packages anyway. But I'm just offering my demo one that I'm going from, just to make sure that everything works. So they may be slightly different to the final result, but all of the logic is there. So if you're interested in getting your hands on that early, then that is one of the reward tiers on the Patreon channel, as well as the files that I've been using for the speed art. So any assets and art things that I make for the speed level designs, they're there as well. So if you were tempted to support the channel, I also tried to give something a little bit extra back as well, just to say thank you for the support that people are showing. As always though, if you've enjoyed the video or found it useful, then please do like and share the video. And if you'd like to be kept up to date with the latest content on the channel, including the tutorials I'm doing here and the speed level design tutorials I have going on in the other playlist, then do subscribe to the channel. As ever though, thanks for watching, and I will see you all next time.